What we're talking about is a Web3 wallet, which is a digital wallet. And the wallets I'm going to talk about specifically today are going to be on the Ethereum blockchain. I'm going to try to talk a little bit about these topics just in case no one's ever heard of them, but I'm not going to go into too much detail. If you need more information, check out our blogs on Nydeis.com. We go into all kinds of detail. Like if you're really interested in the Ethereum wallets that I'm talking about here, I go into the whole thing about the elliptical curve cryptography and how they're generated, the public-private key infrastructure, all the algorithms used, how they do signing, all that. Tons of detail on our blog on Nydeis.com. Check that out if you want great low-level technical information. But for now, we're going to kind of stay on the high level and let you guys kind of do the research on your own. If you have questions about what I'm going into, ask in the comments. Like as you can tell, I'm going to reply back to you and we'll go into detail. And if you're super excited, hit me up and come join me on the podcast. We can do it over Zoom, or if you live in New York, we can meet up in person somewhere. But hey, I'm all excited about more people being on the podcast and making this as fun as possible. So Ethereum wallets. Ethereum, first off, is a cryptocurrency. But more than just a cryptocurrency, it's also its own blockchain. So everyone's heard of Bitcoin, right? So Bitcoin and blockchain, they kind of go hand in hand, but they're a little bit different. So blockchain is just the underlying tech that Bitcoin runs on. We're not going to go into all that. That's a whole nother podcast in itself. But the whole point is that Ethereum is its own blockchain. So you got Bitcoin over here, you're going to have Ethereum over here. And they operate differently. They have whole different methods as to how the cryptocurrencies work. The main thing that's important on the Ethereum side is that they have the ability to run smart contracts. So smart contracts really is a really horrible name for code that runs decentralized on the Ethereum network. And to run this code, you have to deploy it up into the blockchain and then kick it off using functions and all kinds of fun things. But underlying pinning thing of everything is your wallet. Your wallet contains your cryptocurrency, which would be your Ethereum or other ERC20 tokens. You've probably heard a lot about NFTs. The NFTs are stored on your Ethereum wallet. There are other networks out there like Solana and Arbitrum and these other ones that have their own NFTs and their own cryptocurrencies as well. But for today, we're only going to talk about Ethereum and the Ethereum network. So with an Ethereum wallet, there's a bunch of different ways that you can set this up. The easiest way, which is what I mentioned before in the previous podcast, is using MetaMask. MetaMask is a software wallet that's a plugin in your browser. So if you use Brave and not Chrome, because if you care about your privacy, you'll be using Brave, go on there, download the MetaMask plugin, and set it up. It's super simple, very point and click, guides you through the whole thing. So what you're going to do is when you download MetaMask, install the plugin, you're going to create your first wallet. And when you create your first wallet, it's going to guide you through and it's going to show you what's called a mnemonic phrase. It's going to be 12 words. Those words are your private key. Don't ever show them to anybody. Don't write them down on a piece of paper. Don't save it. Don't write them into a notepad thing and save it in your Dropbox so it puts it in the cloud. That is what you want to have completely air-gapped from the internet so it can never be retrieved ever. Because if anyone ever gets that private key, they own your wallet. If they own your wallet, they own all the cryptocurrency in it, they own all the NFTs you've ever bought with it, and they own your identity with it, which we would use to sign messages to prove you are who you are, aka logging in with your self-sovereign digital identity. So be very, very careful with that mnemonic phrase. You don't want anyone to see it. That's the most secure password you ever want to have. Okay, let's think of it that way. So once you have that done, once you have the MetaMask completely installed, that's it. You're gonna see a large hex string on top. It's gonna be 0x and then some letters and numbers in hex across the top. That is your public address. Now, if you want to see what your private key looks like, because you're just messing around, if you go up and you click on edit in your account, you can go down and export your private key, and what you're going to get is a longer hex version of the private key. Using both the private key and that mnemonic phrase that you saw will allow you to restore your wallet should you ever lose it or you ever want to import it onto something else. So let's say you install it on your computer, and you're doing everything, you're like, oh, hey, I want this on my tablet, or I want to put it on my phone. Well, what you can do is you can take that private key or that mnemonic phrase, and you can import it into those devices, into MetaMask or other wallets, and then you now have access to all of your funds and everything else there as well. Now, other forms of wallets, so those are software wallets. MetaMask is the most popular. There's a bunch of other ones out there. Play around with them as much as you want, but really all it comes down to is that there's a public key, again, that hex string, 0x whatever, that goes across the top, and then you have your private key that you never share with anybody. The way that these wallets work is very simple. You go to, let's say, some form of a Web3 app or some type of a D app, which is a distributed application, and you want to log in. It says, hey, click here to log in. You click here, it says, and then MetaMask will pop up. And a little message will say, hey, you're now signing into whatever this application is. Click here to sign this message. And there's a blue button there that says sign. You click the sign button. What's happening is that text is then being cryptographically signed with your private key. And then that message is being sent back to the server. The server then can then take your public key and that cryptographically signed message and prove that you are the signer and owner of that wallet, of that public address. And now it knows, okay, you've verified that you are who you are. I'm going to let you in as this person with your identity being that public key. And this is how all wallet systems work within the Web3 ecosystem, is you sign a message with your private key that you never share with anybody, and you share your public key with everybody. So you sign in with your public key, sign the message with your private key, and you're now logged in. That's it. That's really the basis. It's actually very, very simple. The underlying tech is pretty crazy, but how it all works is very simple. So software wallets obviously are just keeping your public-private key stored on the software. So now what you're thinking is, hey, well, I have $1,000 worth of crypto, or this identity is extremely important, or I have a really cool, awesome JPEG ape, and I want to keep it super safe. Well, if that private key is on my computer, and let's say someone gets a hold of my computer, or they hack my computer, or whatever, well, they're going to get access to my private key. Totally possible. So what do you do now? How do you keep your keys even safer? So this is when we talk about hardware wallets. So with a hardware wallet, you have your public address, again, the hex number that you share with everybody. You can keep that on your computer. And then your private key is stored on a physical hardware device. So here, this is a Trezor hardware device, you can see here. And this is where the private key is stored. It never leaves this device. I mean, you can export it if you want to, but that kind of defeats the purpose, right? So you have your Trezor device. There's a little application that you can install on your computer. You can see there's a little USB port here on the bottom. So what happens is when I go to a website and I need to sign a message to prove I am who I am, I give them my public address to log in, which is on the computer. And they'll say, okay, hey, it pops up, I need you to sign this message with your private key so I know you are who you are. So you plug this into your computer, and then on here is a little screen, and it'll show a little message in combination with MetaMask, and it'll say, hey, push this button to sign the message. So you have to physically push the button with this thing attached to the computer to sign the message with your private key. And now I've proven that I am the owner of that wallet, and then whatever transaction or authentication can now take place. So now, to get access to my identity or my funds or my cool NFTs, you have to have this in your possession. Also locked on here, you can have this protected with a PIN, just to be able to access things to turn on. And then to access the wallet on here, you can even have a password that makes, so you need a PIN and a password just to get this thing to turn on to be able to sign a message. And if you want to go a step farther, there's what's called hidden wallets. So when you plug this into the computer, you put in the PIN and you put in the password, and it says, hey, which wallet do you want to pick? And you pick that wallet. Well, it could be a wallet that's not even pickable. So you have to give it a password for a wallet that's not even listed. So you can make it even crazier. So you can really lock down your crypto and your digital self-sovereign ID with a hardware wallet that you have physical access to. So now I can take this, I can put this in a safe, I can have this locked away in a bank vault, I can put it in you can do whatever you want with it, but unless someone has this, no one will ever be able to get my stuff. They'll never be able to hack it, brute force it, phish it from me, nothing. No social engineering attack can ever get the private key out of here because I have no idea what it is. A couple things I like to do with hardware wallets, a little kind of a tip and trick that I use, is on the back with a Sharpie, I write what wallet it is. So this one's one I store Bitcoin on. I have a bunch of others. Maybe I have one with maybe like my kid's name on it because that's the one I put all my kids' crypto on or whatever. But then also I etch it with a knife. I'll carve it in here just in case this thing smears or whatever. So this way I always know which one's which when I'm kind of fumbling around with them. It makes it just easier in the long run. Now, let's say what happens if this thing catches on fire and melts, or I snap it in half. Uh-oh, right? Like all your money's gone, right? Well, can you sign a message anymore? No, your private key is now permanently gone. So what do? This gets back to that mnemonic phrase. So when you create your wallet on a hardware device, like a hardware wallet, Trezor, Ledger, any of these things, you get a mnemonic phrase, just like with MetaMask. You get those 12 words that you save just in case you need to ever restore your wallet. So the same thing happens here. So I have my mnemonic phrase of this hardware wallet saved. So I could snap this thing in half. I'm not going to, but I could snap this thing in half. I could set it on fire. I could incinerate it, whatever I want to do. And I can restore it onto another hardware wallet or a software wallet if I want to, because I have that 12-word mnemonic phrase. I'm not going to show it to you. But what I am going to show you is how I store my super important mnemonic phrase to make sure that it never gets destroyed and I can always have access to it, but it's securely locked down. So one, I use the hardware wallets for my private keys. Then what I do is I get this thing. It's called Billfoldle, Billfodl. It's a joke on HODL. But this here, stainless steel, it opens up. And what happens is it comes with this piece here and all these. I'm not sure if you're going to be able to see this, but these are also stainless steel. These are punch cards with letters and numbers, capital, uppercase, lowercase on both sides. And what you do is you take that word, and let's say your first word is, I don't know, awesome. So the first letter is A. So you go to the A's, you just pop it out like this. There you go. And now I have the little tab for A. And then what you do is you just take this thing here and you slide it all the way in. Oops. So now you can see here, I don't know if you can see, it comes out or not, but it says like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are the first 12 words. And then here is 13 through 24. So this holds up to a 24-word mnemonic phrase. And what you do is you put all the letters in there. Once it's all done, you close it up. And now with this stainless steel awesome thing, which is virtually indestructible, your mnemonic phrase is safe from all kinds of natural disasters, all kinds of fun stuff, right? So now I'm like, I can rest easily knowing that if this thing gets destroyed, it breaks, it stops working, whatever, I have this to where I can always recover it. I always have access to my identity, my funds, and everything. Now, what you can also do, you see this little thing here, see this little hole? So what I like to do is one step farther. Get these little locks here from the local hardware store. Take this, goes right through there like that. Lock it up. Now you can't open it. So now you need a key to open this lock, to flip this open to get my mnemonic phrase that's stored in a safe somewhere off-site. This key, once I'm done, I'm going to snap this key in half and I throw this away. So if I ever need to get in here, I need bolt cutters to snap this thing off to get access to my mnemonic phrase. So this is what's awesome about digital identities and just the Ethereum wallets in general, or any wallets, really, you can do this with Bitcoin as well, is that they can be as secure as you want them to be. So it could be as simple as, hey, I use this all the time. I'm going to use this to log into my application. So therefore, that private key is stored on a software wallet. It's in MetaMask. It's on my computer. It's always available. But if it were to ever be compromised, it's not really the end of the world. I don't really keep too much on it. And then, I have more stuff where it's like I keep actual funds for transferring. I'm going to put that on a hardware wallet because I really just don't want anyone to have, I want to make sure my money is safe. So I'm going to use the hardware wallet. Well, now I have like a lot of funds. Let's say I have like 10 Bitcoin or something, which is running like 200 grand or 300 grand nowadays. And I want to make sure this thing is safe and backed up, and I don't have to worry about it. Well, now I'm going to drop the $100 for this hardware mnemonic phrase holder, lock it up, and then I'm going to store this somewhere super safe. So it's up to you as to how secure you want to keep it. And this is why we developed Tier. So Tier is our single sign-on passwordless platform that uses Ethereum wallets to log in using standard federation with any application out there that supports SAML, OAuth, OIDC logins, and many others which we're developing on continuously. So instead of using a username password or using Google to log in or using what everyone else is calling a decentralized identity, we are using a truly decentralized ID, your Ethereum wallet, as your login to log into anything that supports traditional federation. So we can use our Ethereum wallet to log in with PingFed to log into their backend apps. We can use our Ethereum wallets to connect to Strata, which is the orchestration tool that will then protect all of our backend applications within our organization. We can even, let's say we're working for some government sites. Well, what kind of passwords are you going to use? What kind of PAM solution are you going to use to protect those hyper secured passwords for the root system accounts of national intelligence secrets or massive weaponized systems, right? So what are you going to do now? Well, passwords are extremely susceptible to breaches. So what do we use? We can use tier to protect this using a private key that's in a hardware thing that's tied with a hardware wallet that we keep locked in a safe where there's a guy standing outside with a gun protecting it. You can't get more secure than that. And that's why we built Tier, is we want a truly decentralized identity platform for single sign-on, for federation, for easy access, and for logins. But we want the flexibility of anywhere from a super simple login all the way up to massively complex security, all run under one single place with a single web platform.